This is the answer key for homework number 6, Finance 499, Spring 2019. In Task 1, we use the Gordon Growth Model as our sample. We're going to calculate the value of a stock using the Gordon Growth Model. It says take next year's dividend and divide it by R minus G, where R is the required rate of return and G is the expected growth rate in dividends. We can rewrite that as the initial dividend times 1 plus G, so that compounds it for 1 year into the future. Our task is to build a one input, one output data table. I've already done the calculation for you. Here's our input section. We have a $2 dividend, a 12% required rate of return, and a 4% growth rate expected in the dividends. Here's the value of the stock, and you'll notice I use a special equation here. Let's have a look at that equation. The Gordon Growth Model can only be used if R is greater than G. Otherwise, we simply can't use the model. We'd end up with a negative stock price if we did. And so what I did down here is I tested to make sure that R is in fact greater than G. If it is, I go ahead and calculate it as last year's dividend times 1 plus G divided by R minus G. On the other hand, if this is not true, if the required rate of return is equal to or less than the growth rate, then we can't calculate the stock price using the formula. And so then I put the NA formula or function into the cell. Okay, that prevents it from calculating invalid values. Let's go ahead and build our data table. We start by setting the blue cell here equal to the value of the stock. That's our data table output variable. Then we highlight the entire table, but not including the headers. And we go to data, what if, data table. Notice that our required rates of return are all in a single column here. That's our column input. So we'll click on the column input cell, and the required rate of return is here in cell B22. We'll go ahead and click OK, and Excel will create the data table for us and plot the stock price. Notice that for the first 4 values of the required rate of return, we returned an NA value. That means that the required rate of return was less than or equal to the growth rate of 4%, and so we can't calculate the stock price. Using this feature comes in handy because Excel will ignore these values when plotting the curve here. So for any value less than 5%, Excel simply ignores it because of the NA function here in those cells. This completes task 1. Task number 2 asks us to build a one input, two output data table that calculates the required rate of return and the value of the stock for values of beta from 1 to 2. Similar setup to our prior task. I've given our inputs here, and we have 2 outputs to calculate. We're going to calculate the required rate of return using the capital asset pricing model. It's the risk-free rate plus beta times the return on the market minus the risk-free rate. Then we calculate the value of the stock as we did before. So I said if the required rate of return is greater than the growth rate, then we'll take last year's dividend and let it grow at G% for 1 year. Then we'll divide by R minus G. If the test is false, that is, if the required rate of return is less than or equal to the growth rate, then we return a value of NA in the cell. Okay, so we'll come down here to our data table. We'll set the data table output variable for the required rate of return equal to cell B28. And the stock value equal to cell B29. We'll highlight the entire data table, not including the headers, and we'll go data, what if, data table. We'll notice that beta is in a single column here, and so we'll use the column input and click on the cell containing the beta. When we click OK, Excel will calculate the data table for us and plot both the value of the stock and the required rate of return. Again, for some values of beta, we can't calculate the stock price because the required rate of return would be less than or equal to the growth rate. This concludes task 2. Task number 3 asks us to build a 2-input, 1-output data table. Let's have a look at our data table. We have different values for the growth rate and dividends along the top, and different values for beta along the left-hand side. There's only one output here, and that's the stock price. So we'll set the blue cell, the data table output variable, equal to the value of the stock. Then we'll highlight the table and use data, what if, data table. Now we have both row and column inputs. So let's have a look here. All the growth rates are in a single row, so we'll click in the row cell and click on the growth rate. All the betas are in a single column, so we'll click the column input cell and click on our beta. When we click OK, Excel will complete the data table for us. Again, notice that some of the values are returning NA, and that's because of our formula here. For high growth rates, it could be higher than the required rate of return, and so we cannot calculate the stock value for those combinations. This concludes task number 3. Task number 4 asks us to read in the values for the PE ratio on a stock, and then decide whether it's a value, core, or growth stock, depending upon the level of that PE ratio. Next, we'll read in the market cap, and then decide whether it's a small, mid, or large cap firm based on those market cap criteria. We're going to use if-then-else statements in Visual Basic, and we're going to use a sub, which is in Module 1, and it's called Calculate the Stock Style. We'll notice that this button here is tied This button is tied to the macro called Calculate Stock Style. Okay. I've already created a module for you, Module 1, and it has a shell for your sub. So what I did is I declared 2 variables for you, a PE ratio and a market cap. And then here's the sub called Calculate Stock Style. So I've given you some hints on how to proceed here. It says first, read the value for the PE ratio and the market cap in the variables that we declined. So we'll say PE ratio is cells. The PE ratio is here in cell B27. Excel refers to that as 27, 2. That is row 27, column 2, and we'll get the value from that cell. Then the market cap is cells 28, 2 dot values. In other words, read the value from cell 28.2, that is row 28, column 2, and put that value into our variable called market cap. So we're finished with the first part of our effort here. We'll move on to the second part. This is the tough part. We're going to use if-then-else statements in order to determine the PE ratio, the style, that is, based on the PE ratio and the market cap. Okay, so let's do that. We'll start with the PE ratio. I'll say if PE ratio is less than 10, then. Well, if it's less than 10, then it's a value stock. So we'll write that value out to the output cell. I'll say cells. This is cell 31, 2. So cells 31, 2. Oops. 31, 2 dot value equals, and we said it's a value stock if it has a low PE ratio. Else, we'll say if the PE ratio is greater than 20, so now I'm going to test the high end here. So I already found that they're very low PE ratios, we'll call them value. If they're very high PE ratios, I'll call them growth. If they're somewhere in between, they default to core. Say then cells 31, 2 dot value equals growth. then we'll say, if that's not true, then it must be a core stock. We'll end this if, and we'll end the first if. So we have two if tests here, 1 and 2. So I need to end both of those if statements. All right. So that will handle the core or mid here. I'll go ahead and delete these values so we don't see them. Now we'll come down and do the same thing for our market cap. So I'll say if market cap is less than 2,000, then we know it's a small cap stock. So we'll write the value out to cell 32,2 over here, the bottom green cell. So we'll say cells 32,2 dot value is small for these stocks. Else, we'll do the other test. If the market cap is greater than 10,000, then cells 32,2 dot value equals large. So we've tested the extreme values. Otherwise, we know it's a mid-cap stock. We need to end this if, and we need to end the first if. So we have two if statements. Here's one, and here's the second, and so we need two end ifs. Should work now. Let's see if it does. So if we have a PE of 15, that should be a core stock. And if I have a market cap of 5,000, that should give us a mid cap. So let's give it a try here. Seems to work. We'll lower the PE ratio below 10. Say the PE is 8. Now it should be a value stock. We'll raise the PE above 20, say 25. Now it should be a growth stock. Next, we'll play with the market cap. If it's less than 2,000, let's say it's 1,000, should be a small cap stock, and it is. And if it's greater than 10,000, we'll call it 12,000, should be a large cap stock. So it seems to be working for all three values on the PE ratio and for all three values on the market cap. This concludes task number 4. Task number 5 is very similar to task number 4, except we're going to use the select case in select statement to calculate the stock style rather than using if statements. We'll see this is actually easier to do than the if statements once we understand the concept. So let's come over here. I've already created module 2 for us. This button is tied to module 2. Let's have a look there. Calculate stock style 2. So sure enough, here's that stock style 2 right over here. So we can go ahead and start. First thing I've done is declared ratios to hold the PE ratio and the market cap. Let's go ahead and read those values. So the PE ratio is, we look in cell 27,2 and we get its value. The market cap, we look in cell 28,2 and get its value. Okay, we have our PE ratio and market cap read in now. We're ready to go ahead and calculate the stock style. So here's the process. We say select case PE ratio. We say case is less than 10. If that's true, then we'll write value into the output cell. The output cell is over here. It's cell B31, or in VBA reference, that would be 31,2. So cells (31,2) will set its value equal to value. So for low PE stocks are value stocks. And then we say case is less than 20. So we know it's got to be greater than 10 if it got to this point. Otherwise, it would have set it to a value stock. So if it's less than 20, then cells 31, 2, that value, we'll set that equal to core. Then finally, case is greater than 20. We'll set that output cell, its value, to growth. Then we have to end select. So we start the select here, and we end it here. Always has to be an end. Just delete a few of these extra lines here. Just tighten things up a little bit. Now we'll do the test on the market cap and write the value out to cell 32, 2, B32. Okay. So we'll do the same as we did for the PE ratio. I'll say select case market cap. And we'll say case is less than 2,000. If that's true, then we want to write the word small into cell 32, 2. So cells 32, 2, set its value equal to small. Next, we'll look at the case where it's less than 10,000. That's our next cutoff. So if it's greater than 2,000 but less than 10,000, then we'll set the output cell value equal to mid. Finally, if it's greater than 20, we'll set the output cell's value equal to large. We'll end select, and we should be done. Okay, let's give it a try and see if it works over here. We'll start out with a low value for the PE ratio. Let's set it equal to 5, and a low value for the market cap. We'll set it equal to 1,000. So that should give us a value stock and small. So let's see if it works. Sure enough, it did. Next, we'll raise the PE to a middle value, let's say 15, and the market cap to a middle value, let's say 5,000. That should give us a core mid-cap stock. We'll calculate the style, and it does. Finally, we'll set the PE to something higher than 20 and the market cap higher than 10,000. That should give us a large growth stock, and it does. So our code is working. We've tested it for all possible values. This concludes task number 5. Task number 6 asks us to read in a set of cash flows and calculate their present value. In this case, these cash flows are the interest payments on a bond, $40 a year, and then the interest and principal in the last year, $1,040. We're going to write a sub and tie it to this button. This button is already attached to a sub called Calculate Bond Value. Right there. Okay. That sub is located in Module 3. I've given you a shell here, declared some of the variables for you, and given you comments or hints at how to proceed. So, I've declared variables to hold the yield to maturity, which is over here in cell B15. And then I've declared variables to hold the year. Years go from 1 to 10. And the cash flow, we have a cash flow each year. And finally, an output variable, something to hold that bond value. Okay, before we proceed, we should make sure that cell B30, also known as cell 30, 2, would clear out. So let's go ahead and clear that out. Let's say pick that cell and set its value equal to, and we'll put 2 sets of double quotes. What that will do is clear out any value in the green box down here for our output. Then we want to make sure that we set that bond value to 0 to start, because we have no cash flows read in yet. So I'll just say bond value equals 0. This is just a safety measure to be ensured that we're not holding over some value from a prior calculation. We'll read in the discount rate. Our yield to maturity is the value in cell 15, 2. All right, so now we've cleared out the green box. We've set the bond value to 0 because we haven't read the cash flows yet. And finally, we've read the yield to maturity from cell B15. Okay. It says use the for next loop to read the cash flows and calculate the bond value. Okay. Okay, let's take a stab at writing this code here. So we're going to use a for next loop. So I'll say for year equals 1 to 10. And we do that, of course, because we have 10 years over here. Then we're going to read in the cash flow. I'll say cash flow equals cells. The first cash flow is in cell B18. So if I take 17 and add the year, that'll give me 18 for year 1, row 18, and row 19 for year 2, etc. So we're going to take, there's our row, and the column is 2, and we want to get the value from that cell. So let's look. The first time we run through the loop, year will be set equal to 1, so 17 plus 1 is 18. It'll look in cell 18-2, and it'll read the $40 value and put it into our cash flow. We're now ready to discount that. We'll say the bond value is the bond value. That is, the new bond value is on the left and the old bond value is on the right. Currently, that's holding a value of 0. We set it to 0 up here. We'll say the new bond value is the old bond value plus the cash flow discounted at 1 plus the yield to maturity raised to the power of the year. And that's it. We read in the cash flows and discount them. We'll say next year, and we're done with the for next loop. So this loop will loop 10 times and read each of these 10 cash flows in, discount it back at the appropriate discount rate for the correct number of years, and add it to the bond value. Finally, we're just ready to write out that bond value and we're finished. So the output cell is over here in B30, so we'll say cells 30, 2 dot value equals bond value. And we're finished. It should work now. So we'll go ahead and test our code, see if it works. We know that whenever the discount rate is equal to the coupon rate, and so this bond must have a 4% coupon rate to pay $40 a year in interest. So in this case, our yield to maturity is equal to our coupon rate. We should get a $1,000 bond value down here. Let's check and see if we do. Sure enough, there it is. If our discount rate is equal to the coupon rate, the bond should sell for $1,000. If our discount rate is lower than the coupon rate of 4%, the bond should sell for more than $1,000, and it does, $1,085. Finally, if our discount rate is higher than the coupon rate, remember the coupon rate is 4% to give us those interest payments, the bond should sell for a discount below $1,000, and it does. So we've tested reasonable values and gotten reasonable outputs. We're good. This concludes task number 6 and homework number 6.